Hello, my name is Landon Ross, and today I'm going to be going over my Lab 2 on charge tapes revisited. This is a continuation of our first lab, so it's going to look very similar, but we're going to look at the same experiment from a different perspective. So here's an overview of what we're going to be going over in the presentation. So we've got an introduction, and then miles and experience, followed by code, some discussion questions, and then we're going to conclude. So the purpose of this experiment is to compare the results in the charge tape lab when using a line charge model instead of a point charge model. In order to do our calculations, we're going to have to master some of the fundamental concepts of physics. These concepts are very similar to last lab, starting with Coulomb's law, which states that like charges repel and opposites attract with an inverse proportion of the square of the distance. This is important because it's used to derive the electric field of a rod, which is used in our calculations, and is also pictured to the right. Second, we have Newton's second law, which states that the sum of all forces is equal to the mass times acceleration. Since there's no acceleration in our equilibrium for this experiment, we know that the sum of all forces is equal to 0. This is also true because of the principle of conservation of momentum. And then because we know that the only two forces acting on our charged tape are the force of gravity and the force of the electric field, we know that they must be equal and opposite in magnitude. Also, we use an important concept of gravity, which is that the force of gravity is equal to the mass times the gravitational constant. The results of our first lab were that the charge was equal to a positive 9.338 times 10 to the negative 9th coulombs, and that the atoms to electrons loss ratio was 6.8 times 10 to the 6th. And then in lab 2, we got some different results, finding that the charge was equal to a positive 2.077 times 10 to the negative 8 coulombs. So we can see that there's a pretty substantial difference in charge, with the charge in lab 2 being greater than the charge in lab 1. Getting into the models and experiment, this lab used the same data as lab 1, same format for presentation via the PowerPoint, and we're still using Newton's second law to find force of gravity, which is equal to the force of the electric field. But this lab was also different from lab 1. In lab 1, we treated the tape as a point charge, but in lab 2, we're gonna find the force of the electric field using the equation for the electric field of a rod. And because of this, we're gonna have to change our code up a little bit. Most labs have their assumptions and areas for error. In this lab, we assume that the charges are equal on both pieces of tape, and we also assume that the charge is equally distributed throughout the tape. Unequal distribution of the tape could cause some error in our experiment, and we could also find some error due to loss of charge when handling the tape. Because when you handle the tape, it's possible that electrons and protons are reacting with the environment, and this can change the charge. We were given a template to use in the code, and this was made it very easy. So you can see my code there, and then we created a free body diagram using GlowScript, which is also pictured on the screen now. That brings us into our discussion. So what if you had modeled each piece of your tape as a single point charge, which is exactly what we did in the previous lab. And if we did this, there was a big difference. We saw this earlier when going over the results. And then why are they different? In lab 1, it was more of an estimate of the charge of the tape. Because tape doesn't act, this charge tape does not act as a point charge, since the electrons and protons are scattered all around this tape. So we can see this better in our experiment as lab 2, where we have very small portions, and we have charge spread out throughout all these portions. And then this is more likely to be accurate because this is similar to how it acts in real life. So in conclusion, the purpose of this lab was to compare results in the charge tape when using a point charge or using a line charge. And our result in this lab was a positive 2.077 times 10 to the negative 8th coulombs charge on the tape. And we improved a couple skills. First, we compared different methods and drew different conclusions. And we practice looking at charges as rods. And we continue to use GlowScript to make our models better. Go Eagles.